All right, previously we had expanded logarithms. Now we're going to condense logarithms, and we're doing this with the same base, of course. Now, what we can do is we can apply the power property first, identify the terms that are products of factors in a logarithm, and rewrite as a logarithm of a power. So, maybe you have, oh, I don't know, 1/2 ln. What do we have before? Let's say we had 1/2 ln of x plus 1. Okay, that'll work. All right. Well, we know that we can go backwards and bring that power up here, and that's going to give us ln of x plus 1 to the 1/2. Now, can we simplify that? Sure, we could say that's ln of the square root of x plus 1, and that would make it the simplest form possible. Okay. Now, next apply the product property. Rewrite the sums of logarithms as a logarithm of a product. Well, say we had the ln of x plus the ln of 3. Well, that's going to be the ln of 3 times x. So we had the plus, so we can do it to the product. And now we're going to apply the quotient property. So we're going to go backwards from there. And so if we had the ln of maybe x, and then we had minus ln of 4, well, that's going to be the ln of, now we have x in the numerator and 4 in the denominator. Okay. And that's because we have subtraction. So we know whatever subtracted, that piece is going in the denominator. And so that's what we're going to do now. We're going to start condensing logarithms that have already been expanded, and we're going to put it into a condensed format. All right, so here we have 4, and we have to convert that into one logarithm. And notice they're all base 10, so that's cool. And so now we're going to take, well, we have a log. Now we can do this in one step probably. We can do all the pluses in the numerator and all the negatives in the denominator. So we have a plus 3 here, and then we can take that times. Now we have a 5. That's all we have on the pluses. Now we have on the denominator subtraction 4, and then times 6. Now, one thing to note, we could say, okay, well now this is the log of 3 times 5, which is 15, over 4 times 6, which is 24. And that could be our answer. Or what we could do is we could say, well, does 3 cancel here? And we say, okay, well, 3 will go in here once, 3 in here twice. And so now what that gives us is log of 5 over 8. Okay. Now, does that equal that though? Well, I'd hate to say it, but that does not equal that, because what this would be is if we split it out, that would be log 5 minus log 8, and that isn't what we have here. And so even though we thought, hey, that's going to be cool, we can reduce, because we're always told we have to reduce as much as possible, that's not going to be what we want to do, because those are not equal. And so the true answer in this case would be this one, because we can break 15 apart into 3 times 5 and 24. Technically, we would want to go down to the primes, and so these would be only prime numbers. But we could say, okay, well, we see that there's a 4 and a 6, and then we could take that and log of 3 plus log 5 minus log 4 minus log 6, and we could get there from this number, but we can't get there from that number. So don't reduce when we're going from this to the condensed form, because when you do that, you're not going to get back to that original form. Okay, so that was kind of one of those things. This is usually what we do, but this time it doesn't work, okay? All right, what about this one? Well, this one, if we condense, what we have to think about is, the order we do it, and we have to apply that power property first. So we have to take that, bring it up here, and we have to take that and bring it up there. So that gives us then log of 5, and then plus log. Now at this point, it's x to the 1/2. I'm going to say, well, okay, well, that's a log of the square root of x, because that's what x to the 1/2 is. So that makes it so it's a little simpler. And then I have minus log of 7x minus 1, and then plus log of x minus 1 cubed. Okay. Now, can we simplify that? Well, we have this and this and this are all plus, so those will go all in the numerator. So we have log of 5 square root x times x minus 1 cubed over, now this is subtract, so this is 7x minus 1, and then that whole thing would be in parentheses, and that would be our condensed form of this summation and subtraction and everything else of different logs. Okay. All right, what about this one? Well, here we're going to work from the inside out because we have a 4 and then we have all these things. And so what I'm going to do is I'm going to suggest inside out. So work inside parentheses first. We've done that before. So, we're going to take our 3 up. So then that gives us 4 times log of x cubed plus log x plus 5 minus log 2x plus 3. Okay. Now let's get everything inside of here simplified into one log, and then we can say, hey, you know what? That's going to then have 4 log of something, and then we can take that 4 to the top of the whole log here. So we have a plus, and then we have a minus. So this is going to become 4 times the log. Now this is going to be x cubed times x plus 5 over 2x plus 3. And so we can put that whole thing in parentheses, and then we still have that outside parentheses because there's a 4 times it. Now we can use the power of logs one last time, bring that up here. And so what does that give us? Well, it gives us log of x cubed times x plus 5 over 2x plus 3 to the 4th. Now, can we simplify that? Well, yeah, we could take and simplify this. That would give us log of, well, x to the 3rd to the 4th, that's going to be x to the 12th, and then it's going to be x plus 5 to the 4th over 2x plus 1 to the 4th. And so then that would be our final answer. Now, could have we had done it a different way? Well, instead of doing everything inside of parentheses first, like I suggested, we could have taken 4 and distributed it through, and then at that point we would be done with the 4, but we'd have a 4 in front of all these, and so that would have given us 12 log x plus 4, and then it would have been log x plus 5, and then that would have been minus 4 log 2x plus 3. Then we can take each one of those up, and we would have got log of x to the 12th plus log x plus 5 to the 4th minus, and now we're out of room, log 2x plus 3 to the 4th, and then that and that are positive, and then it's going to be over that, and we're going to give us to right there. So both ways we have the same amount of work roughly. This one we had to multiply at that point. This one we had to multiply at the first point. So it all depends on where you want to multiply it. Okay, so that's really the only difference, but we're doing the same thing the whole way through. We're combining, we're raising to the power, we're doing all that. It's all the same, just depends on if you want to distribute at the beginning or distribute at the end. All right, so let's stop there and come back for more.